Hi. Uh, Good morning, everyone, ladies and gentlemen. Welcome to today's NFE's 198th knowledge sharing webinar. As you have seen, very aggressively since last 2.5 years, continuous knowledge sharing was is happening on most of the Saturday. And today, why we are no, we are going to talk about why we should follow Indian standard for electrical design for better safety. So you all know that BIS have released the new National Electric Code of India 2023. We have completed almost 30 workshops across the country. And today we will talk about why we have to refer IS standard, not any other country. So Mr. Gopakumar as a moderator, and we have speakers who will talk about it. So I'm very honored to serve as a host for today's webinar, and I want to thank BIS for supporting this webinar. So, electrical safety is a vital pillar of modern structure. Whether it is home, workplace, industry, safety standard not only protect lives but also ensure efficient and reliable operations. So today we will discuss how Indian standards are shaping safer environment, empowering stakeholders like policymakers, industries, and individuals. So today our speaker and panelists will provide valuable insight, and also I would urge the participant, if you have questions, so there is a Q&A box where you can put up the question there. Our moderator, Mr. Gopakumar, will pick up those questions and discuss among the panelists. So I would urge everyone to put your question answer only in Q&A box, not on the chat box. So chat box, we will not be able to record those questions. So my humble submission, please post your question only in Q&A box. So we'll pick up the relevant questions and discuss among that. So let's understand what is NFE. We've been talking about NFE. It's the National Federation for Engineers for Electrical Safety. The passionate engineers have come forward because there is no association for electrical engineers. We have for manufacturers, but there is no association. So in last, I would say 20 months, we are going to complete 2 years in the month of March. We have broken all kind of records. We have done 30 seminars, more than 190 webinars. We have 2,000 members, and we have 7 chapters. One of the most active and most fastest growing society in India. We definitely want to ensure that all electrical engineers become part of this association. It's a non-profit organization. Our vision is to make every electrical installation free of accident. You've seen so many accidents. We pray, when you want to pick up a newspaper and want to read, you always pray that I should not read any major accident today. But unfortunately, day before yesterday, we had a major fire in Tamil Nadu, a city called Dindigal. So there were people, 7 lives are lost. It is not, that's a topic that we have discussed, not because of a fire. It's because of negligence. People are suffocated in the elevator. So we'll take up those questions at the end of discussion. But our vision is very, very clear. Make every electrical installation free from accident. Our mission is to strive hard to achieve our vision through getting accredited for products, personal certification, which shall focus on electrical safety design, manufacturing, installation and maintenance of electrical product, and installation by competent. I'm stressing on this word, installation by competent and qualified manpower using quality resources, including product process and procedure. That's the vision of NFE. So we have been creating awareness on electrical safety, improve the skill of practicing electrical engineers, and improve safety measures followed in the industry. So these are the vision, mission, and what we do in NFE. It's very simple for all of my friends. You choose the membership that you wish to have. We have individual membership, we have corporate membership for MSME, we have discounted uh, membership fee that you can see here. And this is the QR code. Those who wish to become a member, I would urge, please visit our website, NFWES org, and you'll find a link to become a member. NFWES WES.org. So, myself, my name is Dominic, and I've been hosting this webinar. I'm from the fire industry and would love to interact with all the gentlemen today. And we have a moderator who's quite familiar face in the electrical engineers community. He is the founder of CAPE and CAPE Electric Power, LP consultant, and member of technical committee, various committee of BAS, including ETD 20, ETD 30, ETD 50, and very much involved in National Building Code 2016. And there's a revision which is happening. We're expecting in 2025 have a new National Building Code coming in, and you could see sea of changes in the NBC also. He's also a member of TC 64, TC 80, and SE 37A. So he is going to be our moderator and the president of NFE. So we have our General Secretary of NFE, Mr. Appavu sir. He is an electrical engineer and former Chief Electrical Inspector to Government of Tamil Nadu during 2015. He is a certified energy auditor and freelancer in advising electrical safety and earthing practices. His experience include the electrical installation design, practice of LV and M installation as per CA regulation 2010. So he conducts electrical safety audit, electrical accident and fire causes analysis he does. So made paper presentation for India in Japan under the Indo-Japan dialogue on energy conservation and has undergone training in Germany in the calibration of reference electrical energy standards. We have third panelist, young Krish Theobald, is an electrical designer who has no nonsense approach on electrical safety. His expertise lies on LV installation, LV electrical installation design for commercial and large scale domestic installations. So his specialization is achieving on the ground compliance with IEC 60364 based national wiring regulation IS 732 and SP 30. He is a technical director of Protego Plus and technical director of TNG Electro Tech Private Limited. He's very actively involved in BAS. He's a member of BAS ETD 20 and ETD 50, and he's also a member of IEC TC 64 and is a visiting faculty member for NFE capsule courses at NITS Noida, which is BAS training center. So today we have esteemed speakers. I would like to unshare. So I would like to welcome our moderator, Mr. Gokumar, to take this session forward. And I'm requesting once again, please put your question Q&A only in the Q&A box, not on the chat box. Over to you, sir. Mr. Gokumar, welcome back.
Good morning. Good morning, Mr. Dominic. Good morning to all the participants. We are back, I think, after 2 or 3 weeks now. In between, we had some workshops as well. So today we are going to explain the importance of why we professionals should follow or why we Indians should follow Indian standards in India. The sequence of the program is first I will make a small introduction, then go to Mr. Krish for a small explanation about how the IEC standards are made. Then come back, I will explain about the basic safety requirements explained in the standard, then come to Appav sir for further adding up of the standards and the how the things are used in the country. So now let me share the screen. As you can see, what is this international standard? All of you are aware of the United Nations, the World Trade Organization, the technical barriers to trade. Basically, technical barrier, TBT agreements are made by all the member countries of WTO to ensure that the products and services are common to every member country. So the idea is anybody can manufacture, and everybody makes follows the same system all over the globe, not only for products but products and services. According to TBT, there are three recognized, in order to follow the same system, the standardization plays a major role, very important role. Now there are three recognized international standards: ISO, IEC, and ITU. ISO, all of you knows what is ISO. International Standards Organization. IEC stands for International Electrotechnical Commission, and ITU stands for International Telecommunication Union. So these three organizations makes the basic standards, or the global standards. Each of the member country can adopt the standard. The member country includes America, the European nations, and almost all the nations in Asia. They can adopt the international standard and make minor modifications, not fundamental modification, make some minor modification which is suiting to their environment, such as climate, historic reasons, and so on. So first, I would like to invite Mr. Krish. Krish, can you explain how these international standards are made? You can share the screen and you can explain with the uh,
Yeah,
guide.
sure. So I have with me, currently I've opened up the IC website, and this is accessible to anybody regardless of whether you're a member or not. If you go to the IC website and look at news and resources, so I'll just start from scratch. So if you just go to ic.ch, it'll automatically direct you here. You go to news and resources, reference material, and over here there's a bunch of information. Firstly, we have the ISO IEC directives part 1 plus the IEC supplement, and we have the ISO IEC directives part 2. These are the key documents that govern the work that go on in IEC and ISO. We're mainly concerned with IEC, of course, but the procedure is fairly common between the two. The ISO IEC directive part 1 talks about the procedures for technical work, and this is procedure specific to IEC. So, um, how is technical work carried, like done at the IC level? So there is a whole bunch of content. This is basically the governing structure essentially. So when we talk about the development of international standards, there are there is a variety. See, firstly, each committee. So for example, an IC, one of the committees that I am in, Mr. Kupakumar, and we're just in Manila, is TC64, which is the Electrical Installations and Protection Against Electric Shock. So each committee actually has a strategic business plan, and then that goes around, evaluating the work necessary, so on and so forth. Then we talk about projects. So firstly, there's a preliminary stage, then there's an NP, so that's a proposal for a new work item. It goes to preparatory stage, which would be a working draft. Goes to committee stage, which is a CD. Then it goes in IC, it becomes a CDV, and then after that it goes to FDIS, and then it becomes an IEC standard. And at each level, national committees, so that's for every country, that be India, United Kingdom, United States, Germany, Philippines, Australia, New Zealand. All of these national countries can nominate, can comment on these, and they're also welcome to nominate experts on the relevant maintenance teams, project teams, or working groups or subcommittees that deal with these. Um, then, if we talk about how the actual standards are supposed to be written, one of the most important things are, some general principles. So, for example, if we look at this clause 5, it talks about how requirements and standards need to be objectively verifiable. So, for example, you never find something like sufficiently strong or of adequate strength because these are not verifiable. These are highly subjective, so you'll never find these in an international standard. Another important thing is duplication. You'll never find two international standards that deal with the same subject. So it clearly says before standardizing any item or subject, the writer shall determine whether an applicable standard already exists. If it is necessary to invoke a requirement that appears elsewhere, this shall be done by reference, not by repetition. So very important then again. Um, I'll go a little further to expressions of verbal form, and you'll see what I mean. This is very important. Verbal forms are the expression of provisions. So there's certain ways you're supposed to write in an international standards, and that's the way they're written. And this is mainly to do with the ease of use. So, for example, you're only supposed to really write as recommendations, permissions, possibilities, and capabilities. But once again, the key requirement is the requirement. So the user of the document shall be able to require to identify the requirements he or she is obliged to satisfy in order to claim conformance. Beyond that, recommendations, permissions, possibility, and capabilities are secondary. But the most important point is requirements, because that is what govern whether conformance to that particular standard, whether it be document, whether it be a standard, technical specification, technical report, publicly available specification, so on and so forth, is available. There are so then you're only supposed to write these in a certain verbal form. So it says it is essential to follow the rules of verbal form so the clear distinction can be made between requirements, recommendations, permissions, possibility, and um, capabilities. Additionally, to avoid misinterpretation, only the verbal forms that are defined in table 3 to table 7 are allowed to be used. So, for example, if it is a requirement, there shall be a shall. For example, connectors shall conform to the electrical characteristics specified by IEC 60603 7-1. It has to be written in the imperative mode, which is a particular way English is written. If it is a shall not, it is supposed to be written as a shall not. Again, same there. Should. Wiring of these connectors should take into account the wire and cable diameter of the cables defined in the 61156 series. Again, this is not a requirement, it is a recommendation, it helps the user. Permission. So, for example, something may be allowed. So, IC 60512 26100 may be used as an alternative to IC 60512 27100 for connecting hardware that has been previously qualified to IC 6067337-3. Possibility and capability. Something can or cannot. Use of this connector in corrosive atmosphere can lead to the failure of the locking mechanism. The difference between a may and a can is clearly defined because may means that it's permission, whereas can means that the ability of the user to do something or the ability of a possibility. External constraint, of course, is must. This is not used very often in at least electrotechnical standards because this is talking about external constraints. So, because Japan is a seismically active country, all buildings must be earthquake resistant. This generally comes in for some sort of an external constraint. So, either legislature or something like that. Again, we don't really use this much in the electrotechnical industry. And must and shall cannot be substituted or by may or by sorry by must. Very important there. So there are clear guidelines that talk about how these standards have to be written. And I'd also the last thing I'd like to talk about is the various type of documents. And actually there is one last. So if we look at apart from standards itself, we have technical specifications, publicly available specifications, and technical reports. So these three are also published. The final thing I'd like to talk about is in this Annex SD, and this talks about oops, yes, sorry, it would be Annex SC, where countries can make specific exceptions, inclusion of text concerning particular conditions in certain countries. There are two kinds of these exceptions. Conditions of a permanent nature, for example, obviously there's a different mains voltage frequency or climate is very pertinent for India. The statement, such a statement is included in the body of this draft international standard. And if there's a differing practice, so for example, something is done a different way, This is included in the forward or in an informative annex. Very important because oftentimes you hear that no, you cannot use an IEC standard in India. But that's not true because at a level when the standards are being made, the experts nominated from BIS indicate these national considerations and these are recorded in the standards. That's very important again. Anyways, that's it for me. I hope that answers that question to a degree I could. Thank you.
Yes, that's correct, Krish. So the participants got a small idea on how the standards are made or what are the contents of the standard. Let me go back to my presentation. Now, as we said, there are three organizations, ISO, IEC, ITU, where all the member countries put their opinion, put their points, and make standards along with others. And if there is a national requirement, we are free to add the national requirement in the IEC standard itself as a note. So I see, for example, for the electrotechnical subjects, there are basic safety publications, which talks, these are sometimes called as a horizontal document. Whatever written in these documents, say, for example, IEC 61140, which talks about the shock parameters or the electric protection of electric shock, the basic requirement of protection against electric shock in a electrical environment. So the concept which is made in 61140 must be or shall be followed in all the other standards. So these are basic safety requirement. Then there are group safety requirement, such as example 6033 which talks about again protection against electric shock. It is in an installation what you should do is explained here. Then the product safety standards. So basically, basic safety publication, group safety, and product safety publications are the basic documents which are made. When it comes to our subject of low voltage electrical installation, the standard is the global standard is IEC 60364, which is a compendium of multiple standards. Part 1, part 441, 442, 43, 44, part 5, part 6, part 7, part 8. So multiple parts are there. The same standard is adopted in America as NEC, NFPA 70, but of course the contents, the fundamentals are same, but the contents are a little bit different. I will show you later. BS 7671 also adopts the same standard, but they are free to make changes which is not disturbing the fundamental requirement. Also in Germany, the VDE standard. Of course, in India, you know very well, IS 732 or NEC of India, which is a one-to-one adoption of the IEC standard. And the standard talks about design, selection, erection, and verification of an electrical installation. Now, the problem which we face in India is, in our programs where we are conducting across India, people come with ideas. I am following American standard, I am following British standard, I am following German standard, because sometimes even people may comment that these standards are much better than Indian standard, which is actually wrong. Our standards are also equally good, or I would say in some terms it is much better than the other standard because the local conditions are also considered. So these standards like the European nations, EN or BS, DIN, NF, ANSI, these are national standards and these are influenced by their local historic or cultural requirement. Similarly, there are organizations, the VDE standards, IET, NFPA, UL, IEEE. These are non-governmental organizations, but the government of the respective nation permitted them to make, the national standard. As a result, NFPA 70, National Electrical Code of USA, NESE is in America, National Electrical Safety Code. This is NESE is for the electrical installation outside the building. BS 7671 by IT is recognized, VD 100 in Germany. These are some of the standards which is followed in those nations. And these standards have a very long history. For example, NFPA 70, this is started during 1897 or even much before that in the in the introduction of NFPA 70, you'll be able to see when they started making NFPA 70. So historically, during those days, once when there was no international standards present, the way of drafting the standard was little bit different. So now, if you suddenly change the way of the standard, it actually creates confusion. So NFPA follows the same style, even same nomenclature, same subjects, in the same followed for the last few decades, or sorry, not few decades, more than 130 years. The IET wiring regulation, initially it started during 1882. Then basically, for example, if you look at VDE standards, these 1895. So basically, these standards are very old, in the sense these standards started much before the international standards, and they follow the same system. Now the problem, as all of us know, the confusion between earthing and grounding. As all of us know, earthing is a very confusing subject, not only in India and several parts of the world. So earthing is the word which is used in IEC, grounding is the word used in USA. In India, sometimes people try to interpret as earthing is for the body of an equipment and grounding is for the neutral of a transformer. Power system grounding and body earthing. This is what sometimes people use in India, which is wrong. Earthing is the word. Both are the same. Earthing and grounding is the same. Earthing is used in IEC and in the Indian standard. Grounding is used in Americas. So basically, if we want to follow our nation, we should not use grounding. We should use the word earthing. Now, again, the definitions, let me go to it. So actually, the confusion starts from the definition onwards. I'm just trying to show you the NFPA standard, NFPA 70. Let me try to search on one of the subject, which is, one moment, hide floating. Okay, one of the subject, which is RCD, residual current device. First, I am showing you the IS 732 Code of Practice of Electrical Wiring, and I am searching the word RCD. RCD, residual current device, a mechanical switching device or association of devices intended to cause the opening of the contact when the residual current attains a given value under specific condition. Whereas if you go to NFPA 70, you will not be able to, you will not get a word, the explanation, you see. The RCD is not there in the definition. So instead, what they use is ground fault circuit interrupter. Yeah, you see here, ground fault circuit interrupter. A device intended for the protection of personnel that function to de-energize the circuit or portion thereof within an established period of time when a ground fault current exceeds the value established for a class A device. So basically, the style of calling the device is a little bit different. Now, if you try to use the American standard in India, of course, you have to use then GFCI, and you cannot buy this device from the market. So it's very dangerous that if we start following a different nomenclature or different style in our country, finally we end up with big trouble. Similarly, in IS 732, we know very well that 30 milliampere RCD is for shock protection. You can see here. So the requirement of 30 milliampere RCD, protection against electric shock, automatic disconnection of supply, you need to have a 30 milliampere RCD. Then the 30 milliampere RCD is explained in multiple places. So all of us know very well that, okay, 30 milliampere RCD is for protection against shock. And you can see here 300 milliampere RCD for protection against fire in fixed installation. Whereas if you look at the American, the NFPA 70, and if you try to find out 30 milliampere, you will not find the word 30 milliampere. So you don't have, there is no mentioning of 30 milliampere. So basically, if you follow this the American system, of course, you will be in trouble. You will not be able to get the correct material for your application, correct the services for your particular subject. Similarly, this is what you are seeing is from the IEC 60364-554, the definition, the explanation of earth electrode. As I said, the earthing is the most confusing subject in our nation. I thought of addressing this more. Here you can see the IEC says the following are the examples of earth electrode which may be used: concrete embedded foundation, soil embedded foundation earth electrode, metallic electrode embedded directly, vertically or horizontally, of course, for smaller buildings, metal sheath of or other metal covering. So basically, there is a detailed explanation in the IEC. The same IEC has been adopted as BS 7671, including the article numbers, for example, 542.2.3, 542.2.3. So 542.2.3 of both IEC as well as the British standard explains the earth electrode. But you see here, suitable earth electrodes shall be used. The following type of earth electrodes are recognized for the purpose of the regulation. Now, the sequence has changed. It talks about earth rod or pipe, earth tape or wires, earth plates, underground metal structure work embedded in foundation. That means whatever put as the first in IEC is here sequence number 3. Welded metal reinforcement of concrete, which is already you can see here in the IEC, is the same thing. Basically, the same subject is followed here. But you can see here earth rod or pipe, earth tape or wires, earth plates. So the serial number 1, 2, and 3 is definitely going to confuse the users. The subject which is followed in Indian standard is same 542.2.3, concrete embedded foundation earth electrode, soil embedded foundation earth electrode. So from the IEC. So basically these are the changes. This is an example of a change which is made in a local standard. For example, left side you are seeing the IEC, right side you are seeing the British standard. So the system on the left side is followed in India. Now another interesting subject. 542 earthing arrangement. So here there is a 542 1.2 where provided earth electrodes of an installation shall be connected to the main earthing terminal using an earthing conductor, and then there is a note 2011 version I am reading. An installation does not need to have its own earth electrode. So the subject is very clear, whereas when you come to BS 7671 542.12 supply arrangement. Now here what they say is, for a TNS system, means shall be provided for the main earthing terminal of the installation to be connected to the earthed point of the source of energy. Part of the connection may be formed by the distributor's line and equipment. So basically, they change the content a little bit in such a way that this is suiting their requirement. It is suiting because people have the habit of reading these wordings for several decades. So they made it in this fashion. Similarly, TNCS, TT. Now, you see, there is a difference between the what is written in IEC and what is written in the BS 7671. Now, the definition of earth electrode given in BS 7671 is first is the vertical rod, then the plate, and so on. So, as a result, what happens is people always have the habit of reading the first thing, and then balance we don't read. As a result, misleading or misinterpretation goes to the market. What I am showing you in the video is electrical installations used in some countries which is following the British standard. So what they do is they always think that earth electrode means the electrode vertical rod which is on the soil. As a result, they put vertical electrodes on the foundation of the building, piercing through the waterproof membrane, which creates a much bigger problem of water leakage in future. On the future, maybe after 10-15 years, the entire structure is in trouble. So I would say sometime the changes from the IEC standards give scope for the manufacturers to manipulate the system according to their requirement, according to their place of interest. So it is highly dangerous. Now, the concept of safety in IEC, especially the shock protection, there are basic protection, fault protection, additional protection. You have to apply it based on who handles the electricity, normal, skilled, supervised person, how frequently he is in touch with the earth means an earthed object, and what kind of equipment you are using. With this basic idea, the live part is defined, basic insulation is defined, the quality, how much, what do you mean by basic insulation, how much insulation it should be, what are the voltages it should withstand in normal condition or in abnormal condition, so that people are not in touch with a live part. Then basic insulation plus metal enclosure, the requirements are very well defined in the standard. This is a concept for basic protection. Also, basic protection can be achieved by using an enclosure. So you have the live part, all around the live part, you have to have the basic insulation, which has to have certain quality, certain withstanding capacities of voltage and so on, temperature and so on. Then you have the metal enclosure. Because of the metal enclosure, people don't go and touch the live part. This is an example of a basic protection. Similarly, other protective measure, for example, obstacles and placing out of reach. Obstacle means in certain application, maybe the live parts are visible, live parts are accessible, but what happens is in between, you need to put an obstacle, and this is allowed in locations where skilled people are working. Probably this kind of an installation is required in industrial premises. Similarly, placing out of reach. Placing out of reach in public places, of course, the distances are more, whereas in places where skilled people are working, then the placing out of reach. Example, you have the live conductor. There is a person, it should be at least 2.5 meters away, 2.5 meters height, so that accidentally nobody touches. So these are also recognized as obstacles, and placing out of reach is also recognized as a basic protective measure, but this is applicable for a location where skilled people work. Similarly, in a class 1 equipment, example, live part, you have the basic insulation, you have the metal enclosure. The requirement of basic insulation is very well defined in the standard. The manufacturer is supposed to connect all the exposed conductive parts to a common PE terminal. Now, the minimum resistance between the PE terminal and the body of the equipment is 0.1 ohm. The PE terminal, the external, the incoming PE terminal, the PE conductor has to be terminated to the PE terminal. Protective earthing and protective equipotential bonding and automatic disconnection of supply as a fault protective measure against electric shock must be applied in the installation. So basically, serial number 1 to 4 is about the equipment. Serial number 5 is once when you buy a class 1 equipment, your building should have protective earthing, protective equipotential bonding, and automatic disconnection of supply as a fault protective measure for a class 1 equipment. Similarly, equipments are also, you can see the numbering, the symbol protective earthing, the earthing symbol with a circle, and or the 5019 is a number which can be given for this particular application, or green and yellow. Similarly, double insulation. Double insulation in the sense, in the live part is having a basic insulation, and you have an additional, a supplementary insulation as well. As a result of this double insulation, even if there is a fault, the person who is handling this particular equipment do not get a shock. Example, equipment with 2-pin plug. Similarly, the basic and supplementary equipotential supplementary insulation can be replaced with reinforced insulation, that means very strong insulation. The internal fault is not creating a shock situation. In both these cases, equipotential bonding or earthing is not necessary, and these equipment are called as class 2 equipment, double or reinforced insulation. Similarly, the other safety measure which can be applied is non-conductive location. Non-conductive location means you have class 0 equipment. Class 0 equipment in the sense the live parts are exposed. And the operating voltage shall be lesser than 150 volt AC. You can look at the standard. So there are locations, sometimes the live parts are exposed, means the equipment are class 0 equipment. Skilled people can work in this particular environment, but the entire location is insulated. The complete location is insulated, which is technically called as non-conductive location. So between two class 0 equipment, you have to have, the 2.5 meters. Simultaneously, a person should not touch both these parts. If somebody touches both these equipment, probably he get a shock. Similarly, earth-free local equipotential bonding is also a safety measure, means there is no metallic object in this particular case. Similarly, electrical separation. Electrical separation means, imagine you have a machinery. The input supply of the machinery is going through an isolation transformer into this particular equipment. Even during the first fault, people don't get shock because it's the secondary side of the isolation transformer is insulated. So these are some of the safety measures which is included in the standard. And you can see very well that the equipment are tested with different example for basic insulation. The leakage currents are tested. The continuous voltages are applied for certain time and tested. So basically, class 1 equipment as per the standard means all these tests are already made. Now, with this background, I would like to take up the question to Apav sir. Apav sir, I hope you are
Yes, sir.
able to listen.
Yes, sir.
Sir,
Am I audible?
yes,
Am I
yes, you
audible,
are
sir?
audible. Sir, you know that in our country, this earthing is one of the biggest subject, confused subject. And IEC 61936 is giving very clear recommendation, ISIC 61936. Can you throw some light on it?
Yes, sir. Yes, sir. Actually, we have been trained and by wrong ideas and misconception. As you said, we are providing earth electrodes. Wherever, when a doubt arises, you put on earth electrode. Whether it is VPS or shock, you put on earth electrode. There ends the matter. People think. But the reality, I can cite instead of the standards, I can say one beautiful regulation. Regulation 18 under the Central Authority Regulation 2023, which has come into existence since 1937. Actually, we will be celebrating the 100th year. Even before the evolution of the standards, the regulation has come in India. But, however, what the regulation says is simple. The integrity of overall earthing system of the grid as well as the premises, every premises depends upon the interconnection. The paradigm, we have to see a paradigm shift. The paradigm shift is interconnection. There are earthing materials available subsoil. It can be a rail, it can be a foundation of a building, it can be a municipal water pipeline, so on. So the first thing is interconnection and proximity, where we have a proximity. For example, in a urban station, there is a proximity. These available existence already is giving a term called quasi-equipotentiality. That is what you call no dangerous touch voltage. So the thing is, there should not be any dangerous touch voltage. So to achieve this dangerous, there is no dangerous touch voltage. What are the things we have to provide? It is not the earth electrode alone. It can be a interconnection of suppliers earth neutral terminal at the service mains of the consumer. There ends the matter. If all the consumers interconnect such a thing, then the beautiful interconnection will exist in the downstream. Actually, we are facing with so many problems other than electrocution in the country. We are having so many property losses due to fire and other things due to the over voltage, temporary over voltage. We have so many measures for all the things. We have measures for shock protection, measure for overcurrent protection, measure for lightning and switching protection, but there is no specified measure. A challenging measure is temporary over voltage from the high voltage, that is a supplier's distribution side. It is clearly given in Indian Standard Class 4.5.2.2 of IS 732 in 2019. It prescribes measures how to avoid the temporary overvoltage, how to mitigate simple interconnection. It is not the number of earth electrodes or number of earth connections that you are giving. It is simply the interconnection at a common point, no further downstream earthing. So what people are doing, they are providing so many earth electrodes, that is a misconception. There will be a circulating current and there will be so many things which can affect the people and property. So we have to adapt IS 732 and have a integration, a synergy with the suppliers network, assess a suppliers network and provide our own network to protect our equipment and personnel. This is the thing that I can express, Mr. GK. Do you want anything further? GK sir, okay, I can add few more things. See, what we are having, as already expressed, that Earth electrode becomes a concept. Now, Earth fault loop impedance is the concept. It is clearly given in Regulation 43. Also, there is a specific provision in IS 3043 under class 23 and 24, where they specify that instead of multiple earth electrodes, a TNS system is sufficient, should be provided, or shall be provided, as Christian, shall be provided with a single point earth connection at the entry. So the fault loop impedance is the criteria, not the earth electrode. The fault loop impedance path has a milliohm path, whereas we are depending upon the earth electrodes that constitute several ohms. So grid current, the current division is very less, and your protective device, that is even your MCB or overcurrent protective device, will take care of the shock protection and fire protection. This is a paradigm shift that we have to make, Mr. GK.
Thank you, sir. Thank you, sir. Let me share the screen again. Are you able to see the screen? I am
Yes.
showing the as you started with the earthing. I'm just showing the IS 732, which has written simultaneously accessible exposed conductive parts shall be connected to the same earthing system individually, in groups, or collectively. So that means the class 1 equipment can be connected to the same earthing system, means it's all common for one building, individually, in groups, or collectively. Lot of time, this is a big confusion for in our country. For example, as you know, just as a concept, I'm putting this picture. You have the common bus bar. All these equipment 1, 2, 3, 4 are class 1 equipment. The standard use the word individually earthed, whereas colloquially we use the word dedicated earth. Individually earthed means all these equipment 1, 2, 3, 4 are connected to the common earth bus bar individually, separate. Whereas here on the bottom, what you are seeing is not individually earthed. Probably this can be called as, earthed in group. The problem of earthed in group is, if there is a leakage current in equipment number 4 or some noise, something in the equipment number 4, it will flow through the other equipment to reach the MET. So problem in equipment number 4 is creating or it is disturbing the performance of equipment number 1 and 2. As a result, the manufacturers most of the time they prefer, it depends on the type of the manufacturer, type of the equipment. If the equipment is an electronic equipment, and if the microprocessor is referenced to the body, to the common protective terminal of the equipment, then of course the manufacturer will ask a this one, that is individually earthed system, because he don't want any circulating currents on the body of his equipment. Similarly, these connections, there is a maximum continuity resistance requirement. Let us say, for example, medical location 200 milliohm, but of course 200 milliohm probably is a higher value for a larger equipment. For small equipment, this value is okay. So with this in mind, so basically the standards are very clear. The question is how we should uh, educate, or how we should explain to the participants. Now, coming back to Krish, I have a question. Krish, last week in Manila, in the ICTC meeting, we had an interesting discussion on the fault current calculation. So in
Absolutely.
India, our practice is to have, for example, the transformer and the main panel. We consider the DC resistance of the conductor and calculate the fault current. As a result, the fault current requirement are very high in the main panel. Say, for example, 50 kiloampere or 65 kiloampere sometime. As a
Mm.
result, protective devices are of very high breaking capacities are used in those locations. In fact, in Europe, they have an additional standard, which is not an IEC standard, it is an European standard, which explains that you should also consider the impedance, the inductance of the conductor. And once when you consider the inductance, of course, the value of the fault current reduces drastically. So can you explain, throw some light on this?
Absolutely. So, as you mentioned, the current practice in India is to just look at the conductor resistance. So, I have here with me IS 8130, and for class 2 conductors, it talks about conductor resistance. So, for example, if you consider 300 square copper conductor, that has
Are you
about,
sharing the screen? No.
sorry. So I have in front of me IS 8130, and this is the standard that talks about the conductors in insulated cables. So if we look at class 2 conductors, it mentions here that a 300 square copper conductor plain wire will have a resistance of about 0.601 milliohms per meter, or ohms per kilometer. So what we do in India is we add this to the impedance of the transformer. But the truth is that the impedance is made out of a resistive component and reactive component. Um, so if we model a situation like this, where we have a supply, and which is say 32.8 kiloamps of short circuit current available at the source, with an impedance of 0.007 ohms. It's not really 0.007 ohms, because this 0.007 ohms is broken down to a resistive component, which is very little. It's only 0.0176. But much more major than that is a reactive component, which is 0.06817. This has been calculated for a particular arrangement with a 1500 kVA transformer. Um, and I'll just show you how this is done manually as well. And then when we add our conductor, say 6 runs of 300 square millimeter copper conductor multi-core, we get a fault current. Now I'll just show you on a spreadsheet. This is the transformer. If we only consider the resistance, uh, we will get a value of about 28K at the end. However, when we consider the resistance and the reactance, then we get a much lower value of 24K. So where a 25K device could have been used, actually you would have ended up seeing maybe a 50K or 36K device being used. simply because of the fact that we didn't take into account the impedance. And just to clarify, what's actually going on here is the opposition to the flow of current is not just by the conductor itself, it's by the it's all there's also an opposition to the flow of current caused not only due to the resistor, like I said, by the conductor itself, but there is an opposition to the flow of current caused by the change in the magnetic field in the direction of the current, which is what we think of as reactance. So that's very important because especially in larger cables, and again I'll just show you. See, in some European standards, they talk about 0.08 milliohms per meter. Now, in smaller circuits, 18.1 is the resistance, 0.08 milliohms per meter is the reactance. That's very negligible. But if we look at anything beyond 240 square mm, then the resistance is lesser than the reactance. So what is European practice is anything above 25 square mm. So point 7 point oh 0.07 point 0.727 is the resistance, then 0.08 is the reactance. So it's a 10% difference. So anything above this 25 square mm, you consider the reactance as well. And this is very important because currently we are not doing this actually. And as you can see, this causes a gross oversizing of productive devices, which will increase costs. The other implication of this is that you may think that you have 28K of current available to cause automatic disconnection, whereas actually you have only 24. So it may result in the fact that your devices may not disconnect. Obviously, this is at this fault current, this is less unlikely, but further down, this may be a significant problem. So, anyways, I hope that answers the question.
Yes, so basically, if the reactance is also considered for this particular case, the fault current of the actual locations will be much lower than what we expect, and the cost of the installation can be reduced, especially the switchgear costing can be reduced drastically. This is what you mean. Am I correct, Mr. Krish?
Absolutely.
Okay, so it saves cost and without compromising the safety or quality of the installation. So, Abhav,
Certainly.
sir, you have any points to add here? You are on mute, sir.
See, yes, sir.
Yeah.
So, as Krish opined, it's a thing that we are yet to follow because the main panel, that is the whether it is a generator or standby generator set or a transformer, we have transformer as per yes up to 2500 kVA. This is permissible for any LV distribution arrangement. But if there are interconnections using, apart from these cables, people are providing a locally fabricated bus duct. These bus ducts will have enclosures and bus bars spaced at various configurations. We are already having a harmonic embedded in the distribution. So all the LV from especially from the main panel to the source will be having a much reactance value than expected. It is more than twice that of the resistance value. There is a specific provision in IS 30909 Part 2. There's a provision to calculate the reactance value for the bus bars as well. They have given various configurations, whether it is a single bus, it's a dimension, length to breadth ratio, and the separation between the bus bars. They have arrived at, with a simple formula, they have arrived at the reactance value. This will be helpful to design the installation so that the OCPD can be set. The setting is important. Apart from the KA rating, the setting is very important. So we have to set the relay of the OCPD so that the expected impedance is not only the resistance, the reactance contributed by this. So that's if, for example, if you provide a sand-twisted bus duct, the reactance will be very low. So we can't. There is no manufacturer's recommendation. There is no manifest data for these things. We have to calculate. This is more important than the cables also. That's what I feel, Mr. GK.
Yeah, thank you. Thank you, sir. Thank you. So, we are in one side, we are trying to educate the people, and we are trying to ask people to use the correct methods and the correct systems. Initially, we were also talking about, before the program, we were also talking about the accident which has happened in the hospital recently in Tamil Nadu, where 7 people died, and we were also talking about the lift. You see, what happens is, let me share the screen and show you some interesting fact, which is very much unfortunate in a country like ours. You see, for example, how people are manipulating the system is the point here. So, in 2021, Government of Maharashtra, the Energy Department made a circular which says that every hospital should have some kind of a special device, NABL accredited device, which is offering all the safety measures of IS 732, and it is NABL accredited, and this has to be used in the hospitals. It has to be used in multi-storied buildings. Parallelly, there was one more circular which says that everybody should go for auditing of electrical installation. This was in 2021. Followed by that, the Mumbai, the municipality, they started asking. You see, you can see here IS 732. They are asking to install this NABL certified IoT. You can see here IoT based microcontroller devices shall be tested and verified by NABL accredited laboratory in accordance with the recognized IS 732. Basically, IS 732 is not a product standard, it's an installation standard. But the Mumbai municipality wanted to put a product based on the installation standard. The complete installation of IoT based. So basically, you can find here. So the municipality is asking to put this IoT based device everywhere in the high-rise buildings and hospitals and so on. Parallelly, the government of Maharashtra is giving an approval for one particular product. You can see the name. This is saying that this product is, you can see here, certificate of accreditation. Government is giving a certificate of accreditation to one company. So here it says that NABL accredited test report. So they are referring to a particular NABL accredited test report for this particular one device which is offering. You can see here the IoT. This IoT based microcontroller device is a real-time data recorder that measures, detect, report, and take corrective action and on different type of electrical mishaps occurring to IS as per IS 732, such as protection from minimizing risk of arcing, short circuit. So basically, they have put something. Absolutely, this is not written in the standard. They are totally spoiling the sense of the standard, and they gave an approval for a particular product. Then what happened is, then parallelly after some time they tried to make that this product has to be made mandatory in every electrical installation. The funny part is, we were in touch with the NABL trying to find out whether this test report is NABL accredited. Now the NABL has written back to us saying that this item, this product, this company, this test report has nothing to do with NABL. Somebody claims that this product is NABL accredited, tested by an NABL accredited lab, but the lab does not have accreditation to test that particular product, because every lab has got a series of items which is accredited by NABL, whereas this particular product and the tests are not accredited by NABL, but they confuse the user by putting their logo or their name in the letterhead or in the test report. As a result, everybody believes that this is an NABL accredited test report. Now we have returned to NABL, and now they have made it very clear. I will read. We wish to inform that NABL provides accreditation services to testing laboratory. First of all, I don't know how the government, the Energy Department of Maharashtra, gave an accreditation certificate to a manufacturer. testing laboratories in accordance with ISO 17024 for specific scope of accreditation. We have reviewed the concerned test report, and also you can see here the concerned test report which is there in the subject of our discussion. Under such condition, the use of NABL or a claim of NABL accreditation is not permitted. However, the laboratory has mentioned a narrative reference being accredited by NABL, which is not acceptable. Hence, we will deal this issue as per the laid down procedure of handling with compliance. So basically, this product is not at all, it has nothing to do with NABL. This product has nothing to do with IS 732. Somebody makes a claim, and the government organizations are trying to make, the government organizations are trying to make some rules, regulations without knowing what exactly is going on. And the funny part is, in 2022, recently there was one more letter. I think this is the letter, the 2022, which says every such IoT based product which is used has to be counted, and the counting, somebody should count how many such products are sold in the market. As a result, everybody knows that how much money is involved. I'm sorry to say that. So Apav sir, what is your opinion on this subject?
Ah, sir, actually, these whole things comes under the ISO IEC 17025. 2017, India adopted its cross-reference standard. You have to adapt. It is reviewed in 2024 also. What does it say? It deals with the general requirements for the competence of testing and calibration laboratories. Actually, it requires a type evaluation report. That means that simply we can say it as a test certificate. You should demonstrate an unbroken traceability chain to international standard. This is the concept. Any test certificate issued anywhere shall have a traceability to international standard. This is as per ISO IEC 17025. How it should be exhibited? The test certificate should furnish the ID number issued by the National Accreditation Body. In our country, this is NABL, National Accreditation Board of Laboratory. Internationally, it is ILAC, that is International Laboratory Accreditation Cooperation. These all are coming under ISO bar IEC 17020 and ISO IEC 17025, and it should be exhibited in the test report itself. Unfortunately, the test certificates are issued by the public sector, where the government is also a stakeholder. That means are we breaking our ISO, IEC norms, our own statutory provisions? Because any design aspect, installation aspect, everything is finally getting vetted by the testing, whether it be a verification for LV installation or touch potential rise for a HV substation. It's all ending with a final validation through testing only. But the test instrument doesn't possess any NABL accreditation for either calibration or testing. That is the pathetic situation. Unless the specific aspect is looked into, then all the basic design, installation, inspection will become futile. That will become waste when the final testing instrument is not calibrated, is not given a test certificate issued by the NABL accredited laboratory. It can be a private laboratory, it can be a government laboratory, but does it have a calibration traceability or testing protocol as per national and international standards? See, we are having so many things that we are yet to follow with our own standards. As already I pointed out that IEC, that is IS IEC 61936 Part 1 is a dual standard. It's more thing. It is more than Bible, Quran, or Gita. It provides everything, whether it is a transformer, erection, earthing configuration. But conveniently, it is forgotten by our own country. We have adapted, but we have not used it so far. So once we touch we forgotten standards, Indian standards and ISO commitment, it is very tough to curtail such unethical manufacturers' practices. This is my opinion, Mr. JK.
Thank you, sir. Thank you. Now we have some questions. Mr. Dominic, if you allow, let me take the question.
Yeah. Go ahead, sir.
Probably if any of the participants wanted to ask a question, probably they can raise the hand and we can allow them to talk. So there is uh, electrical resistance paint as insulator is used in place of ISI rubber mat. Do electrical resistant paint having an ISI number? So is the question. Above, sir, any answer on this? A paint having which is used. Unfortunately, no. You cannot use a paint instead of rubber mat. This is not recognized so far. Probably in future, maybe there can be, but the manufacturer should go to BIS or IEC and they have to standardize the product, the application, the method, and so on, and maybe it will be. But otherwise, until now, no. So,
yes, sir.
Now there is a question from Mr. Sanjeev Kumar. There is much confusion on lightning protection. Still, early streamers are used in a high-rise building. This is not as per NBC. Some PPL defend it by standard fold in France. How it can be implemented so that everyone follow the NBC what IS says. Okay, I would like to answer this question, but before that, let me share the screen. I have opened the NBC, okay. So NFC 17102 is the standard, okay, I think I could not. Let me share it again. The French code, NFC 17102. Okay, but now, first of all of us should understand that every nation has got buildings where lightning protection is mandatory, also buildings where lightning protection is not mandatory. What do I mean by lightning protection is mandatory? Means public buildings, big buildings, taller buildings, some structures, the government decide or the standards making body decide, okay, buildings more than 15 meters, you need to have lightning protection. Public buildings, you need to have lightning protection and so on. So let us call this as case A, where lightning protection is required by law or by a standard. The next case is lightning protection is not required. There are, smaller buildings, means maybe small buildings, houses, and so on. There are several cases where lightning protection is not mandatory by law or a standard in every country. Now, regarding NFC. So, the first answer is every nation has got buildings where lightning protection is not mandatory. Not mandatory means small houses. Nobody bothers whether a lightning protection is installed or not, neither the insurance system nor the authorities. In such cases, ESE lightning protection systems, as per this NFC, is widely used all over the globe because nobody bothers. It is up to the user. If he has got money, he can use something, and it is up to the user to decide. Nobody is bothered. So, 99% of the installations of ESE made for buildings are for buildings where lightning protection is not mandatory. Now, lightning protection, the second case, the buildings, larger buildings, taller buildings where lightning protection is mandatory. Let us look in this case. In France, the lightning protection standard is not NFC 17102. It is NFC EN 62305, which is nothing but the same standard which we follow in India, 62305. All the European nations following EN standards are mandatory. That means lightning protection as per 62305 is mandatory in all buildings in France if LPS is required by law or by standard. Now, where this ESE is used in such condition, you can download the standard and you go to this figure number 1 and also read the entire parts of the standard. You see here, the figure 1 explains how this item to be installed in a building. It consists of a perfect equipotential bonded building, so many bonding, so many down conductors, and finally there is an ESE rod. So in France, what they do is, buildings where lightning protection is mandatory by law, they put LPS as per 62305. Over and above, they put an ESE rod. That means additionally, you put an ESE rod. Whereas the ESE manufacturers in India come and explain to us saying that, sir, one rod protecting 120 meters, one down conductor and one earth electrode. Go to the same NFC standard, go to the class number here, the 5.6 electrical insulation of external ESE lightning protection system. There is a picture and the explanations. Please read this particular explanation. This part of the ESE standard explains that if you have a single down conductor or let's say two down conductors, you are supposed to calculate, or if you have an insulated down conductor, not equipotentially bonded, you have to calculate the separation distance as per the French standard, as per the NFC 17102, which is also the 62305, and you must keep the ESE and the down conductor physically away from the building. You can see here, approach limit of metal elements in the building. S means separation distance. You have to have a physical separation. Now to conclude, if you put an ESE rod in a building of let's say 10 floors with one down conductor and one earth electrode, technically if you read the NFC standard, you have to keep it 2 meters away from the building, away from the entire structure of the building. So basically, I would say NFC 1710 is a very intelligently made product standard, and the Europeans know how to apply it and they don't violate the rules, whereas the manufacturers come with this particular standard in India and educate the whole market saying that one rod, one down conductor and one earth pit, the entire area is protected, which is absolutely nonsense as per this standard itself. Now coming to the technique of early streamer emission, whether it will protect 100 meters or not is a big debate. Scientifically, it is proved that the performance of ESA rod is equal to the performance of a simple 10 to 15 dia steel rod. That means an MS rod and ESA rod are 1-to-1 same. This is very well proven. The enhanced claim is not proven yet. Thank you for this particular question. Coming back to the next question. There is an anonymous attendee, probably to Krish. The question is, what are the advantages considering reactance of conductor?
There are, it's not a question of advantages or disadvantages. It's a question of you need to do it because um, every conductor that conducts alternating current has an impedance, and that impedance is broken down into a resistive and a reactive component. So there is no such advantage. You are required to take into account reactance as well as resistance for the calculation of impedance. And in the case we mentioned, yes, there are cost saving, but as I mentioned, in certain cases, the difference between taking into account reactance and not would be the difference between your device tripping and not. So if I were to answer your question, the advantage of taking into account reactance is your building is safe, your electrical installation is safe. If you don't take into account, your building can catch fire and people can die. So that's what it is.
Yeah. Okay. So there is a question from Mr. Shastri. We have a class 1 equipment. Can we use class 2 component inside and still declare class 1 for the equipment? There is no class 2 component as such. There is class 2 assembly. If you have a class 2 assembly inside a class 1 equipment, and if you wanted to call it as class 1 equipment, then it depends how you are wiring, how you are making the connections. You have to look at the product standard and make it as per the standard. So Mr. Satish Patil is asking earthing area to be kept wet. So absolutely no, Mr. Satish, there is no need for keeping the area wet. These are very old ideas. These are very old and wrong ideas. Don't go behind such ideas. Then there is a question for a 11 kV, 11 bar 415 volt, 750 kV transformer installed on the HT side up to the premise. Mm, the conductor is an overhead line, then underground cables inside the premise through a HT trench. So, such case, is it required to consider the impedance of the overhead line, underground cable, or transformer as well? Krish, you saw the
Yeah. So of course, of course you need to consider. So there is a standard IEC 60909 Part 0. It talks about the resistance of the cables and resistance of overhead lines, as well as the reactance of the cables and the reactance of overhead lines. So absolutely. And then you need to break down the calculation into differing reference methods. So for the overhead line, there'll be one calculation. For the underground, there'll be one calculation, so on and so forth. Because resistance is not dependent on installation reference method, but reactance differs according to the way it is installed. So, for example, in Europe, they say for a multi-core cable or single-core cable in trefoil, you assume 0.08 milliohms per meter as reactance. But if it is spaced, then this value becomes different. It actually increases. So, absolutely, you have to take into account for any conductor, you have to take into account the resistance and the reactance. As I had mentioned earlier, from the example from 8130, we don't take into account reactance for cables smaller than 25 square mm because their contribution to the impedance is negligible. But you can, and it is perfectly acceptable to even do it for a 1 square mm conductor. The point is that it will have no real impact on the calculations. In the case of overhead lines and stuff like that, absolutely. And 60909-0 talks about the values to be used here. Thank you.
Yeah,
Um,
thank you.
Krish, sir, I would like to supplement to Krish.
Of course.
The question Rahul P. Ajit, what he asked is the primary cable from the substation up to the transformer. So our fault loop impedance, if there is a secondary LV OH line, then there is a provision, yes, bus bar, cable, OH line, everything there are provision in IEC C0909 Part 2. For the primary side, it's only a fault, this fault level calculation only it will apply. That is not a major issue. You can assume infinite fault of the substation. Actually, the fault level is kept as a secret for the DISCOM. You have to get it. In all the substation design, we see that the designer is assuming a value of 50 kilo amps. It is totally not relevant to the actual field application. So, in short, for the SV side, you use the fault current calculation from the substation. Coming to the LV side, then you have to arrive the fault loop impedance because the supply is getting isolated. There is a magnetic coupling, galvanic isolation, magnetic coupling through the transformer or generator. So this is my. I just wanted to supplement to Rahul Piaget query. That's all, GK.
Yeah, thank you. Thank you. So, yeah, the next question is from Mr. Anurag. How and when, where and how can lightning protection earth grid be connected with the building earth grid? Also share IEC evidence for this. Mr. Anurag, better you download the National Building Code of India 2016. Go to part 2, section 8, clause 11. There are several figures. There is nothing like building earth separate, lightning protection earth separate. The pictures are given in that. You can download and you can see that. Also, there are some videos in our blog, in our YouTube, where these subjects are explained. So, as a utility, the next question, okay, Mr. Sanjeev Kumar says that they are using this paint extensively and it is also approved by the electrical inspector. Above, sir, any comment on that? Paint for insulation instead of rubber mat.
The same question that you have already answered because the rubber mat, it's not the rubber mat. Nowadays, it is a insulation sheet. There should be, previously, there were rubber mats of sturdy, very high thickness. It is very tough to transport and it gets cracked and within the period of 1 year, it gets cracked. So now they have provided with very good dielectric strength of rubber sheets that is available. If at all you want to provide any coating and other things, it is up to you, but it's not mandatory. Rubber, you provide a mandatory provision first, then you add on the additional provision. It is not a mandatory thing. Provide a paint or something. The sheet will do.
Yeah, thank you. So, Mr. Amit, we have a question. NEC 2023 has included IEEE and NFPA standards are mentioned in our flash study. Mr. Amit, yes, as an information in the chapter part 1, section 22, this is given as an information. But the problem is, selective reading is always a danger. If you wanted to implement the safety in your building, you have to implement the complete requirement of the standard. Example, the basic protective measures, fault protective measures, protection against fire and thermal effect, and all these protective measures are not existing in most of our electrical installation. This is proved during our seminars, technical discussions with the participants. There are several occasions where participants fully agree that there is no fault protection in most of or in their premise all over India. So, whereas those premises, they try to put the arc flash study or arc flash, the requirements of this particular session. So, selective reading is a problem. Don't read it selectively. First of all, you should read the entire document and try to implement it completely. Arc flash study or the additional measures, these are additional measures which can be implemented in a installation which is in compliance to the standard. If the installation is very good, then you make all these things as extra. But if you have only these extra things and no basic safety, then you are in trouble. Thank you for the question. Now, Mr. Satishwaran has made a statement. I think many places, not only India, of the installation did not consider the reactance. The protective device may not trip. When we measure the main PEFC, the fault currents are very less. The solution may be to redo the correction study and change the protection setting. Am I correct? Apav sir, can you answer this?
Yes, he is perfect. This is a perfect study, sir. See, anything you have to design in order to avoid an unwieldy gear and design is a first stage, then installation. Finally, during the validation using a calibrated test equipment, you can find the difference. So based on the test, only you can set the relays and any OCPDs to clear the fault. The impedance value will be exhibited during testing. Whatever the thing, suppose if you consider resistance value alone, then you will have to address the major thing during testing. So you avoid it during the initial stage itself, during the design stage itself, you ascertain the probable loop impedance value for which the reactants contribute a major factor for such locations. Then you can validate the test. During validation, it will be around 10 to 15% error only. Actually, our test earth loop impedance provides two-thirds of the value. This is allowable value is two-thirds of design value. So we are given enough cushion to overcome all the instrument and measurement error. So you provide the initial design considering the reactants as well as resistance value. Then validate the result using calibrated test earth fault loop impedance calibration testing devices.
Yeah.
Okay.
I would
Thank
just
you.
like to add something.
Yeah.
Actually, it's very important that the instrument to have is capable of providing a current for the purpose of the test that is in line with what is actually going to be seen. Because the way these instruments work is that they measure a volt drop created by a test load and then use that voltage drop to calculate the loop impedance. But if you take a regular fault loop impedance tester or a regular continuity measurement instrument and you apply and you use that to measure impedance or resistance in a very large installation, you're going to get completely different values simply because the test current is not enough to actually get the conductors to have a volt drop large enough. So, as Mr. Abavu mentioned, of course, you have to first design and then verify. You cannot say, oh, now the value is different, so I will adjust the rating. That doesn't work that way. And then when you test, also you need to make sure that your instrument is actually meant for the, it is meant for the kind of insulation you're looking at. Because as I mentioned, the volt drop created by the instrument is used for measuring the loop impedance. Thank you.
Yes, thanks, Krish. Now there is a question. Okay, there's a statement from Mr. Gopal Yadav. We have seen many private companies follow global standard instead of national standard. Of course, yes, global companies follow global standard, but sometimes our understanding is the problem. A global company from Germany may be using in all their catalogs, they may be using the references from the German standard. Sometime in India, we think that the German standard is an international standard and we try to follow, which is wrong. So we have to ask the manufacturers of foreign origin or the users saying that, okay, if you are selling a product in India, it should be as per the Indian standard or IEC standard. So of course, a lot of companies now, because of our classes, the awareness is increasing and people start using the international standards. So there is one more question from Mr. Rahul. In most PV installation, the DC side earthing is not connected to the building earthing system, with the solar manufacturer insisting a separate earth. Which standard can we follow this separately? Mr. Rahul, almost all standards explain this particular subject. Let me share the screen just to show you what I am trying to explain. So you can find this is the IS 17. I forget the name of the number of the standard. This is IS 17978. This is, you can see here the solar PV connected to an MET, then finally everything comes to the MET of the building. This picture or this kind of picture you can find in all the solar related standards. Example, the basic design of solar PV is based on this 62548. So here also you can find this picture. This picture of interconnecting the DC side to the building structure or building earthing is common, and that is the correct way explained in multiple standards. So over to you, Mr. Dominic. If any further questions from any participants are there, we can probably take a few questions.
Yeah, we have now 1 hour 34 minutes. Yeah, and there's no questions that's available. We are conducting. If somebody from Tamil Nadu, I would request you to join us in Madurai, and later we'll be moving to Nasik and Pune. Uh, so we will continue to do this standard. Uh, what I call a national workshop on standards and similar topic that we'll be discussing, but slight change after seeing continuous fires in the country across the country. It's not limited to one particular state. We had in Mumbai, then UP with Jain. Then we had in now Dindigul. So the fire is spreading, and I don't know the reason. The actual studies also, we do not have any fire accident. We do not have access to the report. So let's wait and watch what kind of report that comes out. But I would urge all the members who are attending to become a member of NFE. My colleague Lakshmi and Anusha there, they would have posted the link to become a member. We need people, we need good speakers on the subject who can speak on standards. I urge that we are looking for speakers across the country. Please do join, and you can also join as a panelist for the future webinars. We need more people. We need more foot soldiers, and we also need a student chapter across the country. So NFE is want to become the voice of all this, whatever that's happening across the country. We want to become voice to raise our concern. So let's use NFE as a platform to raise these questions. So nothing much more. We will come back to you on the next topic very soon. Thanks for attending. We had a wonderful participation. We have over 370 registration, and I'm sure that most of you attended are members from NFE. Please invite your colleagues and friends also. Apo sir and Gopa sir, thank you very much for joining. And I want to thank Krish also from joining from Mumbai, Apo sir from Chennai. Our president is now currently in Dubai, joined from Dubai. So thank you so much. A final word from President, sir. Anything that you want to address on the fire that is happening across the country? What is that NFE wants to do? What do
Yes.
you think that we should
Probably
talk?
maybe we can make a seminar on especially addressing this fire. We explained about electrical fires in several webinars, but we have to connect it with fire in the sense of what people should do during fire protection also, probably in the next webinar.
Yeah, we would like to do seminars across the country. So, seminar dedicated on why I want to say hospital don't burn. It's not supposed to be burned. So we want to call with a theme called "Hospital Don't Burn." So let's explore and have a seminar across the country. We need people to join hand to do this. Looking forward for this, and we need support of fire department also for this kind of seminar. Thank you so much. God bless you all. Have a wonderful week. We look forward to see you again. Thank you so much. Bye bye.